So it was one beautiful day back in Boston, Massachusetts. I was taking shower. And it just came to me that one of the ideas that I had when I was a graduate student can be actually useful in terms of developing smartphone-based microscope that can be used in all different settings. So I came up with the idea first, the technology idea first, and once I had that, I started talking to clinicians. One of them was Dr. Esther Freeman, and she had an ongoing collaboration with Ugandan collaborators in terms of looking at skin cancer. So the first project was to develop smartphone-based confocal microscope and image cancer suspicious regions in Uganda. Since HIV-positive patients tend to have a compromised immune system, they tend to develop the cancer more often. So that's why cervical cancer is a big problem in Uganda. Also in skin cancer, particular type of skin cancer, which is called carpal sarcoma, is a big problem in Uganda as well. Our smartphone-based devices can be used by either nurses or even like a clinical technician. So it's easy to use and easy to handle. For me, really important part of the development process is to have continuing conversation with my clinician collaborators. So when we come up with initial concept design, we touch base with them and then make sure that it makes sense in clinical context. And I mean, this is not only happening with my Ugandan collaborators. When we develop a skin cancer imaging device, we work closely with Dr. Clara Curiel at Cancer Center. So we always work with the clinicians to make sure that whatever we develop is usable. We have some exciting projects. So for instance, we have one project that is funded by Cancer Prevention and Control Program as a pilot funding. In this project, we are developing even more low-cost microscope device that can visualize melanocytic cells. So currently, what dermatologists uses is something called the dermatoscope. It's essentially a magnifier. So they kind of take a look at skin lesion and see if it's likely to be a skin cancer or not. That's good and all, but it has a lot of limitations. And one big one is that it does not have enough of performance to visualize individual cells. Now, we hypothesize that if we could visualize individual cells, that can be useful for something like a chemo prevention of skin cancer, for instance, right? So if we do the intervention, how do we actually see the progress of that intervention or response to that, right? So there's this lack of feedback tool in the field currently. So through this CPC pilot program, we are in the process of developing new tool called the cross-polarized microscope that can visualize individual melanocytic cells. And so we will be doing some in vivo human imaging study next year in Skin Cancer Institute here at the University of Arizona Cancer Center. No! Jeez, dude!
I thought it was an eye and eyelash.
Oh gosh. You guys been here for how long?
7 years.